It's one of the most recognizable structures on Earth, a bridge so iconic that it defines an entire city, a bridge that seemed impossible to build, standing in one of the harshest marine environments in the world. It has survived earthquakes, storms, war, and time itself. But today, this engineering marvel faces challenges that even its builders never imagined, including corrosion, earthquakes, and a threat from the ocean rising beneath it. Hey everyone, I'm your host, and in today's video, we're uncovering the incredible engineering behind the Golden Gate Bridge, how it was built, how it works, and why it may be facing its biggest test yet. From impossible design challenges to modern-day scientific upgrades, this is the story of one of humanity's greatest engineering achievements. Before the Golden Gate Bridge existed, San Francisco was cut off from Northern California by the Golden Gate Strait, a narrow but extremely dangerous channel of water connecting the Pacific Ocean to the San Francisco Bay. To travel north, people relied on ferries, and by the 1,920 the ferry system was the busiest in the world. But it couldn't keep up. The population was growing rapidly. Businesses needed faster transportation, farmers needed access to markets, and the U.S. military needed reliable movement across the strait. A bridge would solve everything, but almost everyone believed it was impossible. The Golden Gate Strait was considered one of the worst locations on Earth for construction. The water was deep, the tides powerful, and the winds unpredictable. Fog could roll in within seconds, reducing visibility to almost zero. And beneath the surface, the area sits on the San Andreas Fault, one of the most active earthquake lines in the world. Politicians laughed at the idea. Newspapers called it fantasy. Engineers dismissed it as suicidal. But one engineer, Joseph Strauss, believed it could be done and spent more than a decade convincing California that the impossible was possible. Strauss's first proposal was simple and honestly not very beautiful. But the project evolved as top engineers joined the team, including suspension bridge expert Leon Moisseiff and architect Irving Morrow, who gave the bridge its elegant Art Deco style and legendary orange color. The final design was a suspension bridge, chosen because it could span the massive 1,280-meter distance between towers without needing supports in the deep-water channel. So how does a suspension bridge like the Golden Gate actually work? The key is weight distribution. The bridge deck the roadway cars drive on hangs from vertical suspender cables. These suspender cables connect to two massive main cables, each one made of over 27,572 individual steel wires, bundled and compacted. The cables are anchored deep into blocks of concrete on both sides of the bridge, each anchor block weighing over 60,000 tons. When cars, trucks, or wind push down on the roadway, the weight doesn't crush the bridge. It gets transferred upward into the cables, across the towers, and into the ground itself. It's the same principle used in a hammock. The more weight added to the center, the harder the ends pull. And the towers? They rise 227 meters above the sea, taller than a 65-story building. They don't just hold the cables, they bend and flex with wind and temperature changes, keeping the structure stable rather than rigid. Everything, the geometry, the steel, the cable tension works together to form a structure that is strong because it can move, not because it stands still. Before we continue, a quick thank you to today's sponsor. If you've ever connected to public Wi-Fi in a hotel, airport, or cafe, you know how risky it can be. Your data, location, and browsing activity can be exposed instantly. With sponsor name VPN, your information stays encrypted and private, whether you're streaming, researching, or working. You can even switch digital locations to unlock content from around the world. Try it using the link below for a massive discount and extra months free. All right, back to the bridge. Building the Golden Gate Bridge wasn't just difficult, it was borderline insane. Construction began in 1933, right in the middle of the Great Depression. Tens of thousands of workers applied, desperate for a job. but the work was extremely dangerous. First, workers built the anchorages and the two giant towers, one on land and one deep in the strait. To install the ocean tower, workers had to build a massive underwater foundation, working among powerful tides, deep water, and unpredictable waves. Next came the cables, an engineering masterpiece. Workers used a technique called spinning, where individual wires were carried back and forth across the strait by a moving wheel. Over months, these tens of thousands of wires were compressed to form each of the two enormous main cables. Safety was a constant battle. Windstorms could shake platforms, fog reduced visibility, waves could swallow equipment. To protect workers, Strauss introduced one revolutionary safety feature: a safety net suspended beneath the construction area. That net saved 19 men, who later called themselves the Halfway to Hell Club. But tragically, 11 workers died during construction. Finally, after 4 years, the last rivet was driven, and on the 27th of May, 1937, the Golden Gate Bridge opened to the public. On the first day, people didn't just drive across, they danced, roller skated, walked their dogs, and even rode unicycles across the new structure. Today, the bridge isn't just a tourist attraction, it's a vital transportation artery, carrying around 112,000 vehicles every single day. The main cables still support the structure, constantly balancing the forces of gravity, roadway traffic, and weather conditions. The bridge deck expands and contracts with temperature changes, sometimes shifting more than half a meter. Wind is another major factor. The bridge must remain stable even during storms that reach hurricane-level speeds. Modern upgrades have added aerodynamic panels that help reduce vibration and improve wind flow around the deck. Below the roadway, maintenance teams constantly inspect and repaint the steel. The famous international orange color wasn't chosen just for style. It enhances visibility in fog and protects the structure from corrosion. The bridge also includes shock-absorbing joints that reduce strain during heavy traffic and prevent cracking. The Golden Gate Bridge transformed California. It connected economies, allowed tourism to explode, and became a global symbol of innovation and creativity. Entire cities expanded because the bridge eliminated isolation. The region's agriculture and military logistics became dramatically more efficient. But like all major structures, its legacy isn't perfect. A bridge this large disrupts the local marine environment and migration patterns. Decades of traffic also mean continuous emissions. And while the bridge helped economic growth, it also accelerated urban sprawl and heavy reliance on automobiles. There's another issue. The Golden Gate Bridge became one of the world's most tragic locations for suicides. In response, the city has installed a massive steel safety barrier to prevent future deaths. A necessary but heartbreaking reminder that engineering affects more than just infrastructure. Despite surviving nearly 90 years, the Golden Gate Bridge now faces challenges its designers could barely imagine. The most serious threat? Earthquakes. The bridge sits near the San Andreas Fault, capable of producing magnitude 8 or higher. A severe quake could shake the bridge violently and cause catastrophic damage unless constant retrofitting continues.
I'll note the minor corrosion here.
Another threat is corrosion. The Pacific Ocean is brutal. Salt, humidity, and wind eat through steel faster than almost anywhere else on the planet. The bridge's paint isn't cosmetic, it's armor. And then there's sea level rise. Climate scientists predict that by the end of the century, storm surges could reach the roadway level more frequently, challenging the original design assumptions. Traffic growth is also pushing capacity to its limits, requiring improved traffic flow systems and ongoing maintenance. To protect the Golden Gate Bridge, engineers are working constantly. A massive seismic retrofit project has reinforced the towers, roadway, and anchorage points with modern dampers and flexible connections. These upgrades allow the bridge to sway and survive a major earthquake rather than resist and fail. Teams of painters and metalworkers work year-round, applying specialized coatings to fight corrosion. The new aerodynamic deck panels installed in 2021 make the bridge more stable during high winds. Computer sensors now monitor stress, vibration, temperature, and movement in real time, creating a digital health record of the structure. And environmental plans focus on reducing emissions, improving transportation efficiency, and protecting marine life below. For nearly a century, the Golden Gate Bridge has stood as a symbol of human imagination and engineering courage. It represents risk, creativity, and the belief that no challenge is too great. But its future depends on how we maintain, protect, and adapt it to a rapidly changing world. So here's the question. Should we keep upgrading this historic bridge, or one day replace it with something new? Let me know in the comments. If you enjoyed the video, make sure to like, share, and subscribe for more deep dives into engineering marvels around the world. And once again, thank you to our sponsor. Check the link below for your special offer. Thanks for watching, and I'll see you in the next one.